Let's turn our attention now to talking about some of the principal pollutants that we have to deal with in our atmosphere. We will, of course, talk about a lot of chemicals that constitute the principal pollutants, but I'm going to start off by talking about something called particulate matter. Particulate matter is just anything that exists in the atmosphere that um, basically like dust and aerosols and other compounds that are just suspended in the air. So you have aerosols, which are just bits of dust, chemical compounds, whatever, just suspended up in the air and hanging out, kind of like what you see here in this figure. They're actually more like solid particles rather than just individual molecules. They are solid particles. So aerosols are pretty bad because you can breathe them in, and as they come in, they can cause a lot of issues. But then you have something even smaller, something called PM10. PM stands for particulate matter. 10 means that it has a diameter of less than 10 micrometers, which would be 0.01 millimeters. So really tiny. The issue with PM10 is that when you breathe it in, not only does it go into the main body of your lungs, but it can start traveling into the tubes within your lungs too. And once it gets in there, it's kind of hard to get it out. You can get it out. It's just harder, and it can cause a lot of respiratory issues like pneumonia. Now, you can also have even smaller. PM 2.5 is particulate matter with a diameter of less than 2.5 micrometers. This can penetrate even deeper into the lungs, even down into the alveoli. Those are the little sacs, the very ends of all the tubes inside of your lungs. And if you get this particulate matter down there, all the way into the sacs, there is absolutely nothing that will push this particulate matter back out. It's at the end of the line, there's nothing to push it. So it's stuck there. And once it's stuck there and continues to build, it can cause a lot of sicknesses and diseases, including cancer. That's one reason why smoking has recently especially been, what's the word, discouraged. And anyone who's been in who's addicted to smoking is encouraged to stop because smoking, you get a lot of PM 2.5 particles in there. They penetrate into the lungs and cause cancer. Okay, let's turn our attention now to a few of the chemicals that make up our principal pollutants. The four main ones that we'll be looking at are carbon monoxide, sulfur dioxide, VOCs. VOC is short for volatile organic compounds. Another name is hydrocarbons. And we'll also look at nitrogen dioxide and nitric oxides, finishing with nitric acid. Now you can see that by far the largest problem with these pollutants occurs with carbon monoxide. The particulate matters that we just talked about make up about 2% of the pollution problems that we deal with. Carbon monoxide is definitely the worst, and so we'll start off by talking about carbon monoxide. So why is carbon monoxide so dangerous? Well, first of all, it's colorless and it's odorless, and so you never know it's there until it's too late, excuse me. Now, here's why it's so bad. There's a substance in your blood called hemoglobin. It's a substance that picks up oxygen when you breathe it in. It runs by the lungs, picks up the oxygen from the lungs, carries the oxygen throughout the entire body. However, hemoglobin prefers carbon monoxide. The chemical makeup of hemoglobin is just perfect for carbon monoxide. So if you breathe in carbon monoxide, the hemoglobin comes by, sees oxygen and carbon monoxide, it is more likely to take that carbon monoxide, which means you don't pick up the oxygen you need. You basically suffocate. Even though you're breathing oxygen, you basically suffocate because you can't get the oxygen up to the important organs, especially the brain. So yeah, kind of scary. And so that's why it's very important to have a carbon monoxide detector in your home, because there is no way that you can detect it. It's colorless and odorless. You can't tell it's there. And so you need a carbon monoxide detector in your home. So how do you get rid of carbon monoxide if it's there? Well, thankfully, carbon monoxide is removed quickly by microorganisms within soil. So when you have a very industrialized city where there is not a lot of soil around, it's just buildings, parking lots, streets, sidewalks, and nothing else, the carbon monoxide can build very, very quickly. But if you've noticed over the last couple of decades, there's been an increase in the number of trees and grasses that are on the side of the road or built in the middle of parking lots. Those aren't just to make it look nice. The trees and the grass and everything um, have these microorganisms that will absorb the carbon monoxide, and it cleans the air. So if you live in a place where it's kind of dirty and dusty, you want to clean it up a little bit, plant a tree, do something that will help to reabsorb the carbon monoxide. Sulfur dioxide is another major issue. Sulfur dioxide is a colorless gas, not odorless, you can definitely smell it, but it's a colorless gas that is often created through the combustion of sulfur-containing fossil fuels like coal and oil. If you remember in the first video for this chapter, we talked about sea coal. Sea coal was really bad because it was a producer of sulfur dioxide, SO2. Volcanoes are also another big natural source for sulfur dioxide. Now, sulfur dioxide will cause a lot of respiratory problems. So sulfur dioxide by itself is not good for health, respiratory health. But in addition to that, if it floats around in the air, it does a couple of chemical reactions and it produces H2SO4, also known as sulfuric acid. And if you have a bunch of sulfuric acid mixed in the water in the air, well, then that turns your rain acidic and you get acid rain, which we'll talk about in the final video for this chapter. Volatile organic compounds. Organic, it's called organic because it is composed of carbon. That is what organic should mean. You get into food industry, organic means something totally different. But chemically speaking, organic just means it contains carbon. So a volatile organic compound is made of carbon, but also has hydrogen. So volatile organic compounds are also known as hydrocarbons. In other words, made of hydrogen and carbon. Methane, this is the chemical makeup of methane. It is a carbon molecule with a hydrogen molecule attached on all four sides. This is only one example of a hydrocarbon. There are lots of other different hydrocarbons. Many of them are carcinogenic. In addition to that, they react with other pollutants like nitrogen oxides, known as NOx, to produce secondary pollutants. With that being said, let's talk about nitrogen oxides. Nitrogen oxides, or NOx, will be any combination of nitrogen or oxygen that can be potentially harmful. So you have nitrogen monoxide, nitrogen dioxide, and then you have nitric oxide 2 and N2O. That's another one that's can cause a problem. Why is it dangerous? Well, in addition to respiratory issues, it is a key ingredient. It mixes with water vapor and forms nitric acid, which again forms acid rain. Now, NOx is naturally created throughout the world. Now, NOx comes through the decay of plant life, for example. And it also comes from human causes as well. Here's the problem. We have found that the concentrations of NOx are 10 to 100 times larger in cities than they are in the country. And because of that, the potential for secondary pollutants to form and other respiratory issues because of NOx within a city increase exponentially.